Hello. First off, I'd just like to thank my mentors, Ryan Webb and Anna Hermes, both of Instar. Extremely supportive, really made this entire experience really special. A lot of reassurance throughout the whole process. All right, alpine and subalpine region or ecosystems are highly susceptible to climate change. And this makes the Boulder Creek Critical Zone Observatory and the Nowat Ridge Long-Term Ecological Research Sites really important and influential in environmental research. Hydraulic conductivity, or K, is the ease of which water permeates the soil. And these rates can help us estimate the rate of infiltration, groundwater recharge, water availability to surrounding aquatic and terrestrial ecosystems, as well as stream flow into our watersheds. So we used a Decagon MiniDisc Infiltrometer. This picture is on my alpine site, the saddle. Let's see. Up here is the top chamber. There's two chambers, and it's kind of cut off here with a little suction tube. This top chamber, you fill up with water. The top part here, you can slide up and down and adjust the suction according to what soil that you're collecting the infiltration rates with. There's another tube separate that kind of combines both chambers, kind of balancing the pressure between the entire mini disc. And the sintered steel disc here is just a porous disc that has to have good, oh my goodness, surface with the soil. And all of these rates are put into an Excel spreadsheet just to evaluate those rates for us. And these are my locations just west of Boulder, Colorado. My lowest elevations are in Gordon Gulch, Sug and Nug, and these four sites, again, just various elevations. Subalpine, the Sadi, and the alpine site is in the Saddle, and those, the Gordon Gulch sites are part of the CZO, and Nowat Ridge is the Saddle and Sadi sites of the leader. In the next few slides, I'm going to be just talking about the spatial variation, and each plot was 10 by 20 meters. These circled ones are duplicate infiltration rates, which just on these maps, which I made on ArcMap, show the mean of those hydraulic conductivity values. This was the only north-facing slope that we did. You can see a large amount of pine. It's lodgepole pine with a really species-poor understory, not a lot of vegetation, really dense, silty loam soil. I had probably the hardest time collecting infiltration rates at this location. I probably went back about 3 times and did this hike, and redoing most of the sites, I did rates at 30-second intervals with over 10 minutes. This site, I did 5-minute intervals over 35 to 45 minutes. And this all also has to do with the soil texture. We'll talk a little bit more about that too. And within these maps, light colors are slower infiltration rates, and these darker hues are faster infiltration rates. Sug, my south-facing slope in my lowest elevation, had the most variation in soil texture. The soil texture really correlates with the infiltration rates and the conductivity of the soil. These hotspots here is actually where I'm standing in this picture. And here the sand, it moved so quickly I was almost running out of water, and having actually to redo those points a few times and having to change the suction on that mini disc. And the anomaly here, it was just a statistical outlier that we removed with the rest of the data sets and on these heat maps. The Sadi subalpine site, you can kind of see those dark hues start to kind of diminish as we go up in elevation, and the lower infiltration rates, the K values, start to kind of regulate, and it's relatively low infiltration as we go up in elevation. The highest, over 11,000 1,000 feet in elevation in my alpine site. Again, just kind of regulating. This site was a little tricky as well. Fresh snow melt, really saturated soil, and my MiniDisc is for measures unsaturated soil or unsaturated infiltration rates, which eliminates those macropores. And so we're just really getting a true K value specific for that soil type, eliminating the larger pores, those air bubbles, larger crevices. And these areas I did not get points for because they were down here in this pooled water. So we skipped those. And just to compare all the sites next to each other. And they're going according from lowest elevation to the highest. And you can really see that the soil texture really correlates with those K values. And so again, that really high infiltration rate, which means that water's flowing very easily through the soil. And then you get down to these like really dense, silty loam areas. And the water, again, this is where the water was pooled the most in this site. It was a little, and in the Sadi, all of this was really saturated as well. It was a little bit drier along the edges. But again, those really do correlate with soil texture, pore size, resistance, and density of that soil. So for Gordon Gulch, in 2009, Eric Braz of, oh my gosh, I forget which college, but for his thesis, he was here in Gordon Gulch, and we took his mean. He used a double ring interferometer, and that's just quite larger of a radius than the MiniDisc that we use. But in comparison, we were able to at least see that my Gordon Gulch rates were within the same order of magnitude with their conductivity, and so that just gives us some confidence with our results that we were getting. Our only north-facing slope. So there's a wide range in variation of those K values, but it's fairly consistent in that north-facing slope. So we have really slow conductivity, really slow moving water through that soil, kind of filled out in the center, as well as really high infiltration rates as well. In comparison, these south-facing slopes, there's a little bit of an inverse relationship where as we increase in elevation, that variation starts to decrease. And as, again, those are those sandy areas. And on the x-axis, those are just the intervals of those K values and the frequency of them. And so really high amount of low conductivity, really slow moving water through the soil. And that really does kind of show up throughout all of these sites. And then here, this is just the frequency of all the values of all the sites. And again, some outliers, some fast-moving areas, and maybe those sandier soils. But for the most part, they are really slow, low conductivity within the mountains here. And these values are really going to help my mentor, Ryan Webb, modeling his snowpack. And this is going to show the interaction of snowmelt with surface and soil water. And this is going to help also with future CZO and leader studies, and just really being able to understand that interaction between snowmelt, water movement through the environment, how and where that water is stored, as well as the nutrient cycles in the alpine and subalpine ecosystems. And thank you for it.